Hey guys, we're going to move to simplifying radical expressions. So just a reminder what a radical is. This is our radical symbol, and inside is what we call the radicand. The entire portion, though, is called a radical expression. So I'm going to introduce something called an nth root. So this we say square root. However, you can have higher than just a square root. We deal a lot with cube root, and you've probably seen a fourth root before. But you can generalize it and say the nth root of b is equal to a. And what that means is if a is raised to a power, its solution is b. So then we say a is that nth root of b. Okay. The little n is what we call the index. So if you ever see the word index in math, it's talking about that number in front of your radical. And I want to look at an actual example with numbers, so this hopefully makes a little more sense. So we know that 2 to the third power is 8. And if you were asked to find the cube root of 8, you would tell me 2. So that's how these two are related. And that way, that's how these two statements are related as well. So we say 2 is the third root, or we call it cube root. So 2 is the cube root of 8. Okay, so there's an example of how that rule works. Just want to look at a couple examples that maybe aren't as common or familiar. So the fifth root of 32. What that's asking is, what do you multiply by itself 5 times to get 32? So it's 2. Again, our justification is because 2 to the fifth power, or 2 times itself 5 times, gives us 32. We can also say the fifth root of 32 is 2. Cube root of negative 27 is negative 3. That's just one you want to become familiar with. And then the cube root of positive 27 would be positive 3. One thing to note, the fourth root of negative 16 doesn't have a solution. If your index is even, you can never have a negative number. Just like we can never take a square root of a negative number, we can't have the fourth root of a negative number, we can't have the sixth root of a negative number, because you're multiplying an even amount of times, and a negative number times itself an even amount of times would give you a positive number. And obviously positive times itself is always positive. However, here it's an odd index, so we can't have a negative solution, or we can have a negative number, which leads to a negative solution. So that's just something to keep in mind. If you were asked to find the fourth root of 16, you can do that, and that is 2. You can also use variables. So you might be asked, what is the square root of x to the fourth? So you're asking, what do I multiply by itself 2 times to get x to the fourth? And you would have x squared. So this is what we're going to focus on a lot today, is the product rule for radicals. So if I have a radical of a product, any nth root of a product, I can split that up into 2 factors. Okay, so for example, square root of 40 can be split into square root of 4, square root of 10. I could have chosen 8 and 5. However, square root of 8 doesn't come out nicely, and neither does square root of 5, whereas square root of 4 does. So this simplifies to 2 root 10. This is what we call simplified radical form, which is what we're going to practice a lot today. Cube root of 57. So a very common cube root would be cube root of 27. I might have misspoke. Cube root of 54, we're going to use cube root of 27 in order to solve that. So cube root of 27 is common. 27 times 2 gives us 54. So notice I broke it into 2 factors. I have the cube root of 27, cube root of 2, and I can simplify the cube root of 2, or cube root of 27, to be 3. So our solution would be 3 times the cube root of 2. Okay, we're going to do a lot of simplifying square roots as well. So it's really important to know your perfect squares. If you want to copy this down, that's fine. But this is just 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and so on. So those are going to be really helpful when we go to simplify these radicals, because we're going to use them to see what is a factor. So 432 can be split into square root of 4 and square root of 108. But then after that, we have to take square root of 108 and simplify that. And that can be broken down into 4 and 27. But then 27 can be broken down into 9 and 3. Well, 3 can't be broken down any further, so now I just simplify. Square root of 4 is 2, square root of 4 is 2, square root of 9 is 3, and then we have times the square root of 3. So our final answer becomes 12 root 3. However, your job becomes a lot easier if you use a larger perfect square to divide this out. So yes, 4 comes out, but that's still a pretty large number. So what I do is go and try larger perfect squares than 4. So try 16, try 36, see if any of those work. You're going to see that 432 can break into square root of 144 and square root of 3. Okay, that makes this whole process condensed down to one step, and it's just 12 root 3 from that point. A couple more examples, but I want you guys to simplify square root of 243. And then here we're going to actually simplify some expressions. So square root of 242 plus square root of square root of 72 minus square root of 48. So break each of these down individually. They break down as such. 121 times 2 gives me 242. 36 and 2 equals 72. 16 and 3 is 48. Okay, that simplifies to 11 root 2. And then it simplifies to 6 root 2 and 4 root 3. And now you can combine like terms. So 11 root 2 plus 6 root 2 turns into a 17 root 2. Minus 4 root 3 doesn't have a common term or a like term, so it just attaches to the end. Here's another one, this time with variables. We have the 4th root of 16x squared plus square root of 4x plus cube root of 27. So we can still break down, this is a product, it's 16 times x squared, so I broke it down into the 4th root of 16 and the 4th root of x squared, and then square root of 4 is square root of x, and then plus 3, because cube root of 27 is 3. 4th root of 16 is 2. And then I'm telling you right now that you can rewrite this 4th root of x squared as a fraction. So x to the 2 over 4. Then simplify here to root x plus 3. Obviously, you can simplify 2/4 to be 1/4. And then here's another fun fact that I would highly recommend remembering. X to the 1/2 power is the same thing as square root of x. So anytime you see a half power, you can rewrite it as a square root, and it means the exact same thing. So that leaves this term to be a 2 root x plus a 2 root x plus 3. So you can simplify it to be a 4 root x plus 3.